Hello folks, and welcome back to Behind Schedule and Over Budget, the show where you didn't bother to check what voltage your power supply was set to before you plug something expensive into it. Alright, so today's episode will be part of a two-parter where we're going to step through and do a quick build of this Cyberdeck. It's not going to be super detailed, but I'd like to at least take or get a record of how this thing comes together and what goes into it. In the future, I'd like to put a lot more detail into the documentation of this, probably do something like an instructable or just a separate document. For the time being, for video purposes, I think it'd be nice to just, again, take two videos. Part one, which we're looking at now, we're going to go through all of the components inside of the system, and then in part two, we're actually going to assemble the system. So yeah, let's hop right in. So laid out in front of you is essentially the core of the Cyberdeck build. What isn't shown here, and I'm still working out, is the sound. But for the time being, I think we can do without sound. I'd like to get this thing built up. I'd like to get a chance to, again, get a feel for how well it comes together and what else is wrong before I get a little deeper into the build. So, again, in the meantime, I think the core of this system is going to be our display, our keyboard, and obviously our Raspberry Pi and our power supply. So yeah, everything's laid out in front of us, so let's take a look and step through each of them and see what they are and what, if anything, is special about them for this build at least. So to start, we've got the keyboard, the JJ50 keyboard. I've already done an entire video about the build of this keyboard. It is essentially unmodified. It's just assembled with its keys, its keycaps, and it goes right into the build. So luckily, because again, this is the most expensive part in the entire design, luckily we don't have to do any modification to this. We just have to plug it in. So we can skip right past this one. Go to, let's take a look next at the Raspberry Pi. So again, what you're looking at here is actually an original Model B. I'll get into it a little bit later, but this is due, well, in part one, because I had one laying around and I started using it to build with, and two, it's a bit to do with power supply issues. The power supply in this unit is an Adafruit PowerBoost 1000C, and all things considered, it's a little underwhelming as far as this build is concerned. I had actually planned to put a Raspberry Pi 3 inside of this unit, but as it stands, I'm having a little bit of trouble getting the power I need out of a PowerBoost 1000. So for the time being, I'm sticking with either a Model B or a Model 2B that I got in the mail recently. I want to test around those two. I'll get into that a little bit more as we get to the power supply and get to a discussion about it. But before that, I will point out there is something slightly special about this Raspberry Pi, and that it's been modified a little bit in order to accommodate this design. And by that, we've added this cable to the underside of it. So this actually comes out, it's connected to a header, and let's take note of the orientation of this cable. So red goes to the left, or voltage on the USB. So take a look at the cable first. It is a female USB to a header. So pretty straightforward cable, fairly cheap. I believe this is, let me focus up on it real quick. Can't focus, it's alright. So it's a pretty cheap cable. These can be bought on Amazon for like $4 or $5, and they're very useful for this build actually, because they allow us to make the connection from the keyboard to the Raspberry Pi, which, you know, the Raspberry Pi does not have an internal facing USB. All four of them face outward, and we want most of them available, but we do need to make at least the connection for the keyboard internal to the unit. So to do that, I did a little trick that I've done before, where on the Raspberry Pi itself, I've actually soldered a set of headers, male headers, to one of the USB connectors. So it looks like, since it's the inside set of pins, that's probably the top USB connector here. So this one's not going to be available when you use the computer in the future, and I'd like to either print or buy a little cap to go inside of that. But as far as the internals are concerned, the header is soldered to each of the, you see them unsoldered here, but this header is soldered to each of these 4 through-hole pins, which connect to power, data plus, data minus, and ground on the USB. Power, data, yeah. So that's connected directly there, which basically gives us a USB breakout on the underside of the board facing in to the system. And then I just added a little bit of hot glue on there in order to hold it in place. So that's one thing. I've done this in the previous build too. It's just a quick and easy way to get you a low profile USB connector that faces the direction you need it to face. In this case, we wanted to go backward into the unit. Then that's where this cable comes in. See, this cable going from a USB female to a header, it allows us to take the cable that comes out of the keyboard and go right from that to essentially a header into the Raspberry Pi. The only modifications done to this cable, as you can see at the end here, there's a jacket and a braided shield inside of here, and I needed to shorten this up. This actually came almost all the way to the end of the cable, to about here, and because of how low the Raspberry Pi sits inside of the case, there wasn't enough room to fit this entire jacket. So the only modification that has to be done to this cable is that the jacket's going to be cut short, or cut off loose or cut back to a certain extent, and then the braid will have to be removed. It's a pretty straightforward process. You just have to be careful with an X-Acto knife so that you don't cut any of the internal cables. Beyond that, once we're ready, again, the female header plugs right into the male header on the Raspberry Pi. When I went to solder this on, I did it with the connector already in place, so I was able to angle it up slightly so I can avoid some of the small surface mount components on the bottom side of the Raspberry Pi, and that's about it. So the other thing I like to do in something like this is at least strain relieve these wires a little bit, and to do that I like to use a little bit of hot glue to just kind of glue them down in place. So I'm going to do that right now so we can talk about that process, because that's a process that's used in a couple other places on this build. It's already been completed in some other places. And something I'd recommend you do if you're going to follow along. So what I like to do is just take these wires, place them down like that, as flat as possible, and then we're just going to get a bead of hot glue. Right? See if we can focus on that. Yep. And this is coming out right next to the power USB micro connector, which I think is a pretty good spot for it. And we'll just place a bead of hot glue right across those wires. And let's give that a second to cool off. Can blow on it a little bit. Once it cools down a little bit, I don't think it's there just yet. I'll probably burn my finger if I try it, but I like to actually press down on the hot glue in order to squish it a little bit to make it or lower its profile even a little bit more. But in the meantime, that's all you have to do in order to, I like to just keep this strain relieved so that there's no tension on the connector that's soldered to the through-hole pins. So, and yeah, that's also done in a few other spots. I do it in some cases if I'm just soldering leads to a component. Kind of see it right there on this red and black wire on the power boost. And then when we look at the display, we'll see that done a lot more as well. So yeah, now that it's cooled, I just kind of press down on that. And yeah, that just pushes it down, makes it low profile enough so that the Raspberry Pi can actually sit properly in the case, and then these wires don't flail around as much. So with that out of the way, let's actually start making these connections. Just focus that up. So that by the end of this video, we should have a complete system connected to itself. So this cable here, this is an unmodified off-the-shelf cable. It's just a USB mini connector. A little blurry there, but I think you can see it. Let's focus up on that. There we go. It's a USB mini connector, so not micro, mini, which is what the JJ50 uses. And the direction of this is actually a left angle. I'm pretty sure it's a left angle because if we hold it with the profile upright, with the larger part up, the connector actually the cable leaves out the left side. We need that because of the orientation of the connector on the JJ50 relative to where the space is available on the in the unit. So we'll see that in the next video as we go to build. For the time being, let's just take this, plug it in. So our left angle USB mini connector goes to the JJ50, and then I'd have rather this been a straight USB connector, but right angle works too, it actually fits. That'll go to the female USB that goes to the Raspberry Pi. So now our keyboard is connected to the Raspberry Pi. So the next thing up here is going to be, let's go to the power boost. Actually, no, let's go to the display. I like to save the power for last. So this is the 7-inch HDMI long runner display. There's not really any modifications done to this display, but there are a few things added to it, and all of that business goes on the back side of the display. That's a little busy back here now, as you can see. So the two main things that have to be done here is that we need to get the HDMI out from this display to the Raspberry Pi, and we need to get power into the display. So in order to do that, first and foremost is the HDMI. What we're using here is essentially the HDMI ribbon cable kit that Adafruit sells. So I'm using a basically a straight HDMI ribbon adapter here that goes to the ribbon cable. The ribbon cable then doubles back on itself, goes across the display, bends downward out the bottom, and then goes to an HDMI right angle connector for connection to the Raspberry Pi. And like I said, in order to hold this all in place, again, this all goes into the display shell, so it should be fairly tight in there, should avoid anything from coming super loose in the future. But in order to hold everything in place during the build and keep it nice and tacked for the, so it doesn't shake loose as you use it, I like to put a little bit of hot glue, some beads of hot glue here, and that holds the ribbon cable nice and securely. So the other half of this is the power. So this was, I don't actually have a link for exactly which one to buy here, but this was just a simple USB power connector. So all it had in it was power and ground, which actually was pretty nice because there were larger gauge wires, easier to work with, and capable of carrying more current, which is good because this is a bit of a current hog, as it uses about 450 milliamps when it's on. So I just cut the USB side of it off, soldered it to just a female header in this case. This is something I had lying around, and essentially you can really use whatever you have. So again, this was nice because it goes to a little box connector inside of the unit. It makes a good solid connection. I think this is actually for probably for RC applications, but regardless, you can use your own, or I can recommend one in the future. But that is how we're making the HDMI and the power connector or connections to the display. I'm just going to bend this up a little bit. So one thing with these ribbon cables is that, again, your mileage hopefully won't vary on this, but I'd like to just give a bit of a warning, is that you can bend these over a little bit. It's probably tighter than it's recommended to go, but you're not going to really do any damage to the traces in here. Don't crease them all the way. Just give them a good bend, and you can form these ribbon cables as you need them in order to get the directions and routes you need. The only other thing of note is that this ribbon cable is 50 centimeters long. It's a little bit too long it's just a little bit long for the application. One thing I did was I doubled it back over itself a few times in the middle in order to shorten it up, and then just taped it up with some masking tape. So that there is essentially the display. Again, no other modifications to it. We just need to do a little bit of work in order to get HDMI out of it to the Raspberry Pi and power into it from the power boost. So let's at least take the HDMI connection, plug that into the Raspberry Pi. Okay. Let me focus up the camera again. There we go. And yeah, let's save off the power until we talk to the power boost. So, final large piece of this build is the Power Boost 1000C. So, first let's get into what was done to this. Not really a lot of modifications. So my personal build, I actually soldered 3 male headers to the enable side for the voltage, enable, and ground, and allowing me to connect a power switch to this. I think if in the future, if you're going to do this build, you can probably just wire this directly to the power boost. For my case, I had a feeling that I was going to be disassembling this a lot, so I wanted to be able to replace this connector if need be, in case anything went wrong while I was disassembling. So beyond that, the next thing that's soldered onto here is lead wires that come from essentially the supply voltage line. So that's the 5 volt that comes out of the power boost or the boost converter, and ground. It's the same thing that comes out of this USB here. Essentially what I'm doing here is I'm using the USB and dedicating it to powering the Raspberry Pi through this short little USB connector here. And then the rest of the unit, for now just the display, but in the future the display and the audio will be powered off of these 2 pins. It's basically because the display itself needed to be broken out to a cable anyway, just because of the way the case comes together. So I figured we're going to be wiring something custom, so we might as well just connect it to the more flexible corner of the board. The Raspberry Pi, on the other hand, it's a lot easier to just bring power in to the USB micro connector in the corner. So at least that saves a little bit of a headache. We can just use a standard connector to go right from the micro connector on the Raspberry Pi to the standard USB connector on the Power Boost. So that's mostly it for the Power Boost. The one thing that's worth talking about, and while I do that, I'm going to just put some hot glue back on this connector, or this wire point, is my experience with it so far. And the issue right now is that going through some testing, I think this is a fairly well-known problem, but it seems that the Power Boost just doesn't have enough power to confidently power this system. Again, it's rated to get about 1 amp plus out of it, and I've clocked this whole system with the Raspberry Pi on, with an emulator running on the screen, as pulling maybe 750 milliamps up to an amp in certain cases. That seems to be putting a little bit of strain on what the power boost can supply. And one sad thing I found is that when I tried to run the Raspberry Pi 3 with this system, I was getting a low voltage warning and the system was browning out. Some of that, there's a lot of things moving in conjunction here, so some of that may be due to some issues that I'll talk about with the batteries in a minute. But also, I just think that the power supply capabilities of the PowerBoost 1000 are really being pushed by this entire system, especially this 7-inch display. So again, we're really getting to the limit of what we can supply with one of these. And I think for the purposes of this build, I'm going to keep this as is, but I'd like to experiment with some other potential power supplies. I have a power bank on the way, and I'm also going to look at a 10,000 milliamp hour power bank. Some of the downsides of that, and some of the reasons why I like the power boost, are that with that unit, the charging connector, the USB micro connector, is very difficult to get to. We're gonna have to break it out somewhere in the board, and again, the output connections are a little tough too. So it's just going to be a bit of a nightmare to adapt it into this case. So I'd like to try that in the future. For the time being, this will run the system. It'll run a Raspberry Pi Model B, a Model 2B, and depending on the battery, we'll get about 3-ish hours out of it, which is not bad. But again, back to the batteries as well. It's another issue, slight issue here, is that one, I'm getting a little bit less battery time with these than I would have hoped. The other problem is kind of a specific to me issue, is that I'd actually designed this around this 6600 milliamp hour battery pack. It just so happens that this battery pack has been sitting dead for almost 4 years since I bought it, and it seems to have lost a bit of capacity in the meantime. Some back of the napkin math, I would have expected to get about 4.5 hours of use out of this, and in a full up test, I only managed to get about 3 hours and 15 minutes. So I think this battery is starting to go dead, or has been slightly damaged just by lack of use. In the meantime, I did buy a 4400 milliamp hour battery that was initially planned to go into this unit, and again, after a test with this battery, I managed to get about 3 hours of use out of this, which I think is actually a pretty good medium, because again, going back to another issue with the power boost, and something I'd like to change in the future, is that unlike with a modern device that you'd be used to using, where if your battery is low, you can plug it into the wall, you can keep using your phone, your laptop, or whatever while it charges. The charging circuit in the power boost cannot supply enough current to charge the battery and keep the system on at the same time. So essentially, you have to keep this system off while it charges, which is a major pain in the butt. Also, again, if you're just because this isn't a specifically designed and dedicated power circuit for this system, I'd rather, if you're going to use this for extended periods of time plugged into a wall, we not be charging the battery as we go. Just let's stick to specifically charging the battery when we need to. So one thing I'd like to add in the future is the ability to switch back and forth between a specific circuit dedicated to being powered from the wall, and then a specific circuit dedicated to being powered from this battery and charging this battery. So that might mean we're going to have 2 USB micro connectors on the back of this, but that's something for the future. The time being, we can power off of this battery here for about 3 hours, and then about a 4-hour charge, and then we can charge the battery through the PowerBoost 1000. We can power the system off of it. We cannot charge and power the system at the same time, which I think is a pretty big downside. And again, something I'd like to change in the future. And again, also, we're not getting as much power as I'd like out of this. So I want to explore other options for powering the system beyond the PowerBoost 1000. This is just something I have experience with. I've built several projects out of this. It's very easy to pick up and go. It has a good form factor, again, because the USB input, or the power input to charge the battery, is on the opposite side of the output. It allows me to face this connector out of the unit and then face the rest of the power output into the unit, which is great for the build purpose. So in the whatever build we go with in the future might get a little more convoluted than this, which is a shame. But again, I do think we're going to have to amend things in order to make it more usable. But in the meantime, this battery is actually dead. This has half of a charge, so let's get the enable switch plugged in. And just to speak on that real quick, pretty quick and easy, this one. It's just a little slide switch that's wired to a 3-pin connector. This doesn't have to be done on your build. If you're doing it in the future, you can wire it right to the board. I just wanted to have this removable in case something goes wrong. So we can plug that in just like that. We can get the battery connected. I believe, yep, shouldn't power on. And then our connector for the display, let's plug that in. All right. And finally, let's power up the Raspberry Pi. Again, we're just going to go right from the USB micro connector to the USB connector on the power boost. And that should be everything, I think. That should be a working system. So let's power it on and see what happens. All right, we got the light on the power boost. We have the light on the Raspberry Pi. The screen is booting up. And hopefully in a second, we should be into the, wait for it. Yep, Commodore 64 emulator. So yeah, this is the core of the system, kind of just laid out schematically in front of us. And this is what we'll be packing in to the casework in the next episode. And let's just see, keyboard is working well. Let's print hello. That's hello world. And then let's go to line 10 and let's run. Alright, so we know it works, which is great. And again, from testing with the 4400 milliamp hour battery, you can get about 3 hours of use of this system with a 4-hour battery charge. It's not optimal, obviously, but again, we're using unoptimized batteries that aren't designed specifically for this system. There's a lot of drawbacks that are going to come from a setup like that. So I think what we're getting right now is not bad. And like I said, in the future, I would really like to have it so that we can have the wall power, if we're going to just power this as a plug-in unit, be a separate circuit from the portable power, so that we can charge this, or that we can charge this and use it on the wall at the same time. Again, a little awkward. You would need 2 charging blocks or 2 power blocks in order to do that. But I think it's better than the current setup where you're not able, if this battery's dead, you're not going to be able to use this thing until it's recharged. That's not the best usability. But yeah, other than that, I think we've got the entire system laid in front of us. So let's, in the next episode, we're going to go on to getting this bad boy built up. And we'll be able to see it be an actual functional computer in a nicely built case for the first time. So we'll see you then.